Okay, question number 3 says the height of a rocket launched upward from a 160-foot cliff is modeled by height equals negative 16t squared plus 48t plus 160, where h is the height in feet and t is the time in seconds. All right, write the equation that you are trying to solve. So I see my son in the background. Everybody say hey, hello. Hello, I just saw my son. Hello, this is Avery. Hello, everybody. All right, so we're solving this function, or we're solving this equation. We're trying to find the zeros, all right? So the equation we're trying to solve is we're basically setting this equation right here equal to 0, and in doing so, it's going to look like this. So it equals 0. Now, we know the only way to find the zeros or to solve these equations is to factor them or to graph them. So we're going to start by looking at the graph. So I'm going to switch over to Desmos, and I'm going to graph the function real quick. So I have negative 16x, and we've got to use this. So x squared, negative 16x squared, and plus, not equals, plus 48x plus 160. Okay, and so we have the function here. Notice though that we can't see the y-intercept. We can't really see the function, so we've got to zoom out. So I'm going to zoom out, zoom out, zoom out, zoom out. I'm going to scroll down. All right, so now we can see the parabola. Notice how it's really tall and skinny though. So if I want to fix this, I can go to the wrench and I can customize my graph. So that's what I'm going to do. I would like for my y-axis to go up to 200. And then I really, based on what I'm seeing here, my x-axis really just needs to go from like, I don't know, maybe negative 10 to positive 10 or something like that. So let's see if we can change this. So we'll go to the wrench, and you are free to do this when you're using Desmos as well. So on the x-axis, we'll change that to, we'll go, let's delete. So I'm going to go from negative 10, and I'm going to go to positive 10. And was it not 110? Positive 10. All right, got it. And then the y-axis, I'm going to start at, let's go a little below 0. Let's go negative 10. That'll be fine. And then for the y maximum, this is just like our TI calculator. So we have like a y minimum and a y maximum. We'll go 200. And then let's count by our step. Let's count by 100. No, not 100. Yeah, let's count by tens. That's good. That's good. Okay, so now I'll bring that back up so you can see it. So notice the x-axis, the y-axis, and so don't worry about radians and degrees. So now we're looking at this, and so we have a y-intercept of 160. If I scroll over here, it looks like I have a maybe an x-intercept or a 0 at x equals 5. All right. I have another x-intercept at x equals negative 2. So in looking at this, remember, let's go back to the question. The question is asking us to find the height of feet in seconds, to solve by factoring. So what we're trying to do is we're trying to figure out basically the zeros. We're trying to find out when this function, when it hits the ground, okay? So when does the rocket hit the ground? That's the question we're trying to answer. And so going back to the graph, this 0 of negative 2 does not make sense. We're not saying that the rocket's going to touch the ground 2 seconds before we launch it, even though it might have been on the ground, but we don't know that for sure. But we do know that we're modeling the height of the rocket by looking at this. So the 160 represents the cliff. This is where the rocket was launched. It goes up to a maximum value. Desmos will give us that maximum value. It looks like the maximum value is 196 feet. When x equals 1.5. So remember, this is the vertex. And then we go down and we find this 0, and the 0 is at 50. So you can see that. So after 5 seconds, the rocket is back at the ground, which is ground level 0, because the y-axis represents the height. So we can see that graphically. We already know that the answer is 5 seconds, but what we want to do is solve this by factoring. So I'm going to factor this for you, and you guys can kind of follow along. The first thing we notice is that obviously the a value is not, where's my cursor? The a value is not equal to 1. So we've got to either factor out a common factor or use the box. So it looks like I can factor out a 16. The reason I know that is I know that 16 divided by 16 is 1. I know 48 divided by 16, the b term, is equal to 3. And I know 160 divided by 16 is equal to 10. Now, we want to actually divide out or factor out a negative 16 because we need our a term to be positive. So I'm going to factor out a negative 16 and show you what that would look like. So it would be 0 equals, factor out a negative 16. Inside, I'm going to have a t squared minus 3t minus 10. All right. And so put this up. I got to find where I'm doing this. Why does it say starting a scan? I don't want to start a scan. Okay, so I got to find you. That's what I got. So notice, I got to find my finger. Notice that now I have an a term of 1, which means that I can now do inverse FOIL. So that's what I'm going to do. Inverse FOIL. 0 equals negative 16. 2 parentheses. So remember inverse FOIL, what I'm looking for is I'm trying to find two numbers that multiply together to give me negative 10 and add together to give me negative 3. So multiply to negative 10, add together to negative 3. And so I'm thinking that the numbers are going to be negative 5 and positive 2, because negative 5 times positive 2 is negative 10. And if I add negative 5 plus positive 2, I get negative 3. So that's the factored form. So we're going to write that down. We're going to write t minus 5 times t plus 2. And so I would say that this is the factored form of the quadratic. That's the factored form of the quadratic. And of course, now I know my zeros. I know that when t is equal to positive 5, it's going to make that parentheses equal 0. I know when t is equal to negative 2, that is going to make the parentheses equal 0. So I'm going to write that down. I'm going to say t is equal to 5 or negative 2. T is equal to 5 or negative 2. 5 or negative 2. 5 or negative 2, 5 or negative 2. Now, I'm going to bring Desmos back up, and I want you to see how that relates to the graph. So when t equals 5 or when t equals negative 2, the output is equal to 0, or the rocket is on the ground. And so if I could find my cursor, you'll see that when x equals 5 or when t equals 5, that the output is 0. And we see that true on the graph. And also when x equals negative 2, that the output is equal to 0. Okay, so that's the way that works. All right, so guys, those are the 3 problems that I wanted to go over with you today. Of course, we did number 1, and we did number 2, and we did number 3. So this is the last video that you'll get on 1, 2, and 3. I do want you to try number 4, and I want you to try number 5, and I want you to try number 6, and I'm going to give you the answers to that. Now, if you have any questions about numbers 4, 5, or 6, I want you to ask those questions in the discussion board. So the discussion board is going to be listed under this assignment in Canvas. And if you will, just give me, somebody trying to, there he is. If you just want to reach out through the discussion board, and I'll try to answer those questions, as they come up. Thanks, guys.